So, systems of inequalities. We learned about systems of equations or linear. Well, no, we did some nonlinear too. Equations last time. There was three ways to solve the system of equations. There's graphing, which we didn't really do because it's hard to do by hand. There was substitution, and then there was the elimination or addition method. These inequality ways to solve these system of inequalities are the only way you can really do it is to graph it, because you'll see why in just a second. So first of all, to graph, just going through graphing linear inequalities, they work the same way as like graphing y equals mx plus b. Except there's two different things that you have to do. So the first one is if it's less than or greater than, you use a dotted or a dashed line. A dotted or a dashed line. This signifies that it cannot equal that. When you have a line, that's all the points that it can be. So if it's dashed, that means a point on that line will not work. And then if it's less than or equal to or greater than or equal to, you do a solid line. So that signifies that it can equal it because it's less than or equal to. And then the second way is you have to shade one way or the other. And that is why we have to graph these, or the easiest way to solve these is to graph them. The way you shade is you pick any point not on the line. You pick any point not on the line, and then I guess if it's true, you shade towards that point. And if it's false, you shade away from that point. And you'll see what we mean when we do these in just a second. Sometimes, if it is in y equals mx plus b form, you can kind of look at it and say, okay, if it's greater than, I shade above. If it's less than, I shade below. But sometimes it gets hard to see those. All right, so it starts with the basic ones. If I have x is less than or equal to 4, if it's x equals any number, what kind of line is it? Anybody remember? It is a vertical line. Okay, so I go to x4, 1, 2, 3, 4. I draw x equals 4. It doesn't really make sense to draw it this way. It says no matter what y is, x is always going to be 4. Okay, so the two things you check. It's less than or equal to, so I am going to have a solid line because it's less than or equal to. Solid line because it's less than or equal to. And now I have to shade. On this one, you don't really have to do the point because we know where x is less than. X is less than this line on this side, right? So I'm going to shade on this side. And on Alex, there's a little like paint bucket that you just drop on that side. So on these, you can just kind of look at it because we know x gets smaller as it goes to the left. So what this means is any point in this area over here will work in that equation. Any point, and it will be true. Okay, so if x equals a number, is vertical, then y equals a number is horizontal. Well, now let me change colors. So y equals any number is horizontal. So I go to y3 or negative 3, 1, 2, 3. Again, it wouldn't make sense to do it this way if you get confused. It says no matter what x is, y is always negative 3. This is greater than. Y is greater than. So I am going to do a dashed line. Okay. So it is dashed because it is greater than. On Alex, there's a little like button that you can just toggle between solid or dashed. And then this is greater than, so we know that y gets bigger as it comes up here. So I shade above the line on this one. Okay, so there's kind of my two differences that I do on the different groups of shading here. I'm sorry, the dashed or solid, and then you got the shade. That's the two differences of the other line. Okay. Why does it keep doing that to me? All right, y is greater than or equal to 3x minus 2. So this one does look like y equals mx plus b. We're thinking those same lines. My m is the number in front of x, which is 3 over 1. So that's up 3 to the right 1. And my y-intercept is negative 2, so that's where I start. So I start at negative 2, and then I go up 3 to the right 1. Up 1, 2, 3 to the right 1. This is going to be a solid line. We know that from the very beginning because it's greater than or equal to. So my line is going to look like this. Okay, now to figure out where to shade. When it is in y equals mx plus b, you can kind of look at it and say, okay, I'm going to shade above the line, so that would be over here. But sometimes that's hard to see, especially when the line starts to get more vertical. It is hard to see. Like, it's kind of hard to tell that this is above. So the way we do this is to shade this, we pick any point that's not on the line. 0, 0 is the easiest one to pick. Okay, 0, 0. So I'm going to shade this, I'm going to pick 0, 0, and I'm going to plug that in. And we're seeing is 0 greater than or equal to negative 2. That is true. Okay, so since that is true, we are going to shade towards that point. That means any point that I pick on that side of the line would hold true in this equation. If I pick a point over here, it would not be true. So any point in this area over here I could plug in and it would hold true. Kind of the same one on this thing. This one, y is less than negative 2x plus 4. So my slope is negative 2 over 1, which would be down 2 to the right 1. And my y-intercept is 4. So I start at 1, 2, 3, 4. And I go down 2 to the right 1. Down 2 to the right 1. This one is going to be a dashed line because it's just less than. Oh, wait, I drew a solid line after I said I just was talking about how it was dashed and I drew a solid. So there's a dashed line. This one is less than or equal to, so if I had to guess, I'm going to shade like over here. But let's pick a point that you have to pick a point that's not on the line to plug it in. So 0, 0 again is easy. So 0 is less than negative 2 times 0 plus 4. Is 0 less than 4? That is true, so I shade towards 0, 0. If it were not true, I would shade away from 0, 0. And again, like I said, some of you may be able to see it only works if it's in y equals mx plus b, but less than you would shade below the line. All right, next one. I don't know why it keeps doing that to me. (3x plus 2y is less than or equal to 12). This one is not in y equals mx plus b, but we can make it y equals mx plus b by solving for it. So we subtract 3x from both sides. We're trying to get y by itself. And then divide both sides by 2. So I get y is less than or equal to negative 3 halves x plus 6. So here my slope is negative 3 over 2, which is down 3 to the right 2. And my y-intercept is 6. This is less than or equal to, so it is going to be a solid line. 1, 2, 3, 4, 5, 6. I start at 6. I go down 3. 1, 2, 3 to the right 2. This is a solid line. All right, so again, let's pick a point to shade. 0, 0 is always easiest to use if you can. You just can't go through there. So plug that in. It's always easier on these to plug it into the original one, the top one, because then it's just 0 on the left side. So 0 is less than 12. That is true. So we are going to shade towards 0, 0. We haven't gotten one that's false yet. Hopefully the next one is. All right, next one. Why in the world? 5x minus y is greater than 10. So same idea on this one. Got to solve for y, so I subtract 5x from both sides. I get negative y is greater than negative 5x plus 10. Then to get y completely by itself because it's negative, I'm going to divide everything by negative 1. When I divide by negative, what happens? I flip the sign, so negative 5 divided by negative 1 would be positive 5. 10 divided by negative 1 would be negative 10. So my slope is 5 over 1, which would be up 5 to the right 1. And my y-intercept would be negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I start at negative 10. I go up 5 to the right 1. This is going to be a dash line, right? Because it's just less than. It's less than right here, right? So dashed. Okay. So especially on like this one, if I'm looking at y is less than 5x minus 10, it does get confusing which side is below. So when we plug in 0, 0 to see which way to shade, again, it's easier to plug it into the top one. Because I get 0 is greater than 10. That is not true. So that it means I'm going to shade away. Put this over here so I can shade. I'm going to shade away from 0, 0. So we hadn't had one where we shade away from 0, 0. But if you plug in 0, 0 and it's not true, you shade away from that point. You shade the other side. Because what this is essentially saying is that any point over here will not work, because that's the side we picked one from. And then any point over here will work. All right, so that's graphing linear inequalities. So now let's do the system part. The system part, all it does is it takes and it puts two of these on the same one. Do you remember when we are solving systems of equations, what the answer is? Like we get a point like 2, 3. Anybody remember? I said it a bunch on Tuesday. Yeah. The intersection point. Yeah. So the intersection, when you have just equations, it's the intersection point. So when you solve these, you have the shading on these. So it's actually the intersection of the shading. That's why we have to graph these to solve them. So we're going to have to graph both of these and then shade both of them. And the intersection of the shading is how to solve these. And I'll kind of show you how to do that on paper. I'll show you one of these with my colors, and then I'll show you the easy way to do it. All right, so the slope is 2 over 1 on my blue one. That's up 2 to the right 1. And my y-intercept is 3. This is a solid line because it's less than or equal to. So 1, 2, 3. And then I go up 2 to the right 1. And there's my blue line. I do need to shade. Scared I'm going to need to make that a little bigger. So to shade on this one, I can plug in 0, 0. So is 0 less than or equal to 3? Yes. If you are doing this on your paper, I'm going to do it a little bit different because I have the colors and the highlighters and stuff. But if you're doing this on the paper, what I would do is just make a little mark on your paper to like shade that way. Don't like shade the whole thing because it gets confusing. So just make a little mark on your paper to remind you that you are shading towards 0, 0. If you were to shade the whole thing, it would look like this. Okay, I'm shading on this side. All right, now let's go do my red line. My slope is -1/1. So that would be down 1 to the right 1. And my y-intercept would be -1. So I start at -1. And I'm going to go down 1 to the right 1. This again is a solid line because it is greater than or equal to. Okay. Now to figure out where to shade on this one, I can again kind of go through the 0, 0 because that is not on the line. So if I plug in a 0, 0, I get, oops, I forgot to put a 0 in for my y. 0 is greater than or equal to -1. That is true, so I'm going to shade towards 0, 0. Okay, so if you made your little mark on the blue line, I need to be to the right of this and above this, so it would be this area right here. I'm going to go ahead and shade all of it just so you can like see the intersection. I thought maybe it'd make a nice little purple here for me. Kind of does. So my answer is only this area right here. This part right here is my answer. That is the only part on Alex that will be shaded for you, and I'll kind of do that like that on the next one. I just want to show you the intersection of the shading. So you shade the red line, you shade the blue line, and the true answer is the intersection of the shading. What in the world? Why is it not letting me click the buttons today? There. All right, y is greater than x minus 2. And y is less than -2x plus 5. My blue one, my slope is going to be 1. So that would be up 1 to the right 1. And my y-intercept would be -2. So start at -2, go up 1 to the right 1. This is going to be a dashed line because it's just greater than, right? All right, shade this one. Let's pick 0, 0. Remember that 0, 0, like that point that you pick can't be on the line. So if your line ever goes through this point, like you got to pick like 1, 1 or something. You got to pick something different. All right, so plug in a 0, 0. Is 0 greater than -2? Yes. So I'm going to, this is what I would do if I was doing it with pencil, is I just put a little mark right there to know that I'm shading above that line towards 0, 0, so I don't forget. Now my red line, my slope is -2/1. So that would be down 2, not 1. Down 2 to the right 1. And my y-intercept is at 5. 1, 2, 3, 4, 5. So I start at 5. I go down 2 to the right 1. It is a dashed line. Let's plug in 0, 0 to shade again. So is 0 less than 5? That is true as well. So this one shades towards 0, 0. So now I can kind of see where my arrows are facing. My answer would be this area right here. So I have to be above the red line, above the blue line, below the red line. So it's just that one answer right there. All right, next topic is, what if you have 3 lines? So y is greater than or equal to x plus 1. Y is less than or equal to 3x minus 2. And then the last one is x is greater than or equal to -1. A lot of time when you have like 3 or 4 or whatever, they just give you one like this. I'm going to go ahead and do this one because it's easy. So this is, remember, a vertical line. It's going to be solid. So I go to -1, solid line. And it's greater than, so x gets bigger as it goes this way. Okay, so definitely on these, just make a little mark because it gets real confusing if you try to shade 3 of these. So make a little mark to remind myself that I'm going to shade that way. My blue one, my slope is 1, so that would be up 1 to the right 1. My y-intercept is 1. So I start at 1, I go up 1 to the right 1. This one is solid because it is greater than or equal to. To shade this one, I can plug in 0, 0, right? It doesn't go through 0, 0. So 0 is greater than 0 plus 1. Is 0 greater than or equal to 1? No, that is not true. So I need to shade away from 0, 0. So right now, if I had my answer, I'd just shade right here, but we still got to add the red line in there. So here, my red one, my slope is 3 over 1. That would be up 3 to the right 1. And my y-intercept is -2. So I start at -2, and I go up 3 to the right 1. This one is a solid line. To shade on this one, again, you plug in 0, 0, because 0 does not go through that line. Is 0 less than or equal to -2? And that is no, right? 0 is not less than or equal to -2. So I need to shade away from 0, 0, which would be this side. Oh, no. Okay, so I need to be to the left of the blue line, to the right of the red line, and to the right of the purple line. So it should just be this area right here. That's the only one that would satisfy all 3 of them. So the purple line doesn't really help us at all on this problem, but it's probably just Grok not giving me a good problem. All right, let's do one more of those. Y is less than 2x plus 4. This one, my slope is 2 over 1, so that would be up 2 to the right 1. And my y-intercept is at 4. 1, 2, 3, 4. And then I go up 2 to the right 1. This is a dash line though, right? Because it's just less than. So when you get to these problems that have like 3, it's very easy to like forget to do that. By the way, when y'all take your test, it is on a computer. You'll have a chance to like review it and look over the problems you missed. If you like miss this whole problem just because you forgot to dash one of the lines, you can tell me and I'll give you points back. Okay. All right, to shade this one, I think I need to restart my iPad. Plug in 0, 0. So 0 is less than 2 times 0 plus 4. Is 0 less than 4? Yes. So I am going to shade towards 0, 0. So I put a mark, just a mark to remind myself. My red line. The slope is -1/1, so that would be down 1 to the right 1. My y-intercept is at 1. So I start at 1, and then I go down 1 to the right 1. This is going to be a dashed line. We can check the shading by plugging in 0, 0. Is 0 greater than 1? No. So I shade above the red line. So right now I'm kind of to like the right or below the blue line and above the red line. So it'd be like this area right here. But we got our third one. It is y is less than or equal to 5. Remember, that is horizontal. It is going to be a solid line because it's less than or equal to. So I go 1, 2, 3, 4, 5 at y 5 right here. I'm going to make that a little bigger, I think. And it's less than or equal to, so I need to shade below. Okay, so I need to be, this is kind of where it gets tricky when you're on Alex on a computer, like, because you can't put those little check marks on the computer. So just kind of write something down to help you. I got to be below the blue line, above the red line, below the purple line. So it should be this area right here. So yeah, just find some way to think about that in your head. I got to be to the right or below the blue line, above the red line, below the purple line. Kind of write those notes as you're graphing them, and then it makes the intersection easier to find. All right, last topic. I really kind of want to look at Alex and how they do this one. Does anybody have this one pulled up? Let me look real quick. You do?
The last one?
Yeah. The nonlinear. I just want to see how they have you graph these real quick, so I can make it the same as theirs. Do they? So you just have to graph the parabola, or do they make you do 2 points?
Mm-hmm.
This button is like the vertex and one other point. Okay.
Do you want us to do this? The linear and quadratic exams?
Oh, hold on a second. The exam?
It says it's due today. Out loud,
Yeah, is
On
that
Alex, it
like on
says
our
it's due
own,
today.
like due tonight?
The homework, the test is?
Yeah, the exam.
Oh, you don't want to take the test today?
I'm down.
I'll go check the dates. I hope I didn't mess this all up. That'd be bad. It's probably Labor Day messed me up with that. Okay. All right, let's finish this and then we'll figure out what's happening there. So remember last week I thought the test was this week, so I did confuse myself somewhere. All right, let's do the red one first here because that's just a linear one. This one mixes parabolas and a line. So here my slope is 1/1, so that's up 1 to the right 1. My y-intercept is 2, so I start at 2. And then I go up 1 to the right 1. This would be a solid line. Nothing new on this part. So got to figure out the shading. So when I plug in 0, 0, 0 is greater than or equal to 2. Well, that's not true. So I shade away from the line. Okay, by looking at her problem real quick, it looked like the way the tool works for graphing parabolas is you have to do the vertex and one other point. Okay? So my vertex, remember, is the opposite of b over 2a, and then you plug it in. You plug whatever answer you get in. So let's write what a is. A is 1. B on this one is 0. Okay? There is no b on this one. That is fine. So I'm going to do the opposite of b, which is 0, and 2 times a, so 0 over 2 is 0. That's my x value of the vertex. So now to find the y value, I just plug that in. Plug in the x, and y is equal to -3. So my vertex is at -3. Now I think you just have to pick one other point to work to plug in. So just plug in like a 1. So if I plug in a 1, I get y equals -2. So another point that I could use is y1 -2. Okay, and that will create, their tool right there will create your parabola for you. To figure out where to shade, it's kind of the same thing, but it's more like inside and outside instead of above and below. So when I plug in a 0, 0, 0 is less than 0 squared minus 3. 0 is less than -3. That is no. Okay? So that means all these points on the inside right here, where 0, 0 is, they do not work. I need to shade away from there. That seems like too much. Too much shading. You know what we can always do? You can't do this on the test, obviously. And it wouldn't be good to do it all the time. But what was it? Y is less than or equal to? You can always check your answer real quick. What was the other one?
Y greater than or equal to x plus 2.
Yeah. So my intersection, you can see where the intersection is. I was just double checking my work there. I have to be above the red line and outside of the blue line. Above the red line and outside of the blue line. So my shading would be like this area and this area. So on the parabola, it's more like inside, outside. Like, is that 0, 0 inside? If it's true, then you shade on the inside. If it's not true, you shade on the outside. All right, let's do one more of these just because this one's set up slightly different. Why is it doing that? Let me draw. So y is greater than x squared plus x minus 6. My red line, y is less than 2x minus 1. Okay, again, we'll do the red line first because it's easier. Slope is 2 over 1, up 2 to the right 1. Y-intercept is -1. So I go up 2 to the right 1. This is going to be a dashed line. To shade, we can use 0, 0 again. 0 is less than 2 times 0 minus 1. Is 0 less than -1? No, right? So we shade away from 0, 0. I'm going to shade to the right of that red line or below it. For the parabola, same thing. You got to do the vertex, the opposite of b over 2a, and then plug it in. So here my a is 1, my b is 1, and my c is -6. Remember, a is in front of the x squared, b is in front of the x, c is a constant that's by itself. So the opposite of b is 1. So the opposite would be -1. 2 times a would be -1/2. Oh, Grok, give me a fraction. That's not nice. I kind of want to change it so it's not a fraction. We'll do a fraction. So now you have to plug that in. So you square 1/2, that's 1/2 times 1/2, which is 1/4, plus 1/2. I'm going to go ahead and write 2/4 there, right? 2/4 is the same thing as 1/2. And then -6. So this is 3/4 minus 6, which is Negative 5 1/4. I believe Alex has a thing where you can have to look at that problem. You still have that problem up over there? Alex isn't going to give you a fraction, but there is a little tool in the bottom left-hand corner of your tool palette that allows you to type in a point. So with that point, you can type in 5.25 or negative 5.25. You don't have to graph a fraction actually. So this is my fault for trusting AI. That's my vertex. All right. We still got to do the point though, don't we? So let's plug in a 1. You can plug in any number you want. Just don't plug in the same number as the vertex. So let's plug in a 1. That'd be 1 squared plus 1 minus 6. That would be negative 4. So another point that is on this graph is 1, negative 4. Plug in anything you want there. So negative 1/2 and negative 5/4, 1, 2, 3, 4, 5, 6 would be somewhere in this area. And then 1, negative 4 would be somewhere right here. So my parabola looks something like that. Oh, we got a shade though, right? So when I shade this one, we can plug in 0, 0. 0 squared plus 0, what was it? It was greater than, I forgot to do something. Is 0 greater than negative 6? That's yes, so I will shade towards 0, 0. What did I forget to do? I forgot to dash the line because it's it is just greater than. So I do need to dash the line. So when I plugged in 0, 0, I got that it's true, so I shade towards 0, 0. So I need to be below the red line and inside the parabola, so it looks like my area is going to be in this right here. If I got to be inside. All right.